Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on January 6, 2026, just 2 days ago. It introduces a framework that allows models to self-improve by critiquing their own work, effectively closing the gap between image understanding and generation to achieve state-of-the-art scores of about 87 on DPG and 89 on CompBench. The paper is titled UniCorn, Toward Self-Improving Unified Multimodal Models Through Self-Generated Supervision. And as we'll see later, the strategy of splitting the model into proposer and judge roles offers a really promising path for training without external data. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the core motivation, which the authors call conduction aphasia. On the top left, a prompt asks for a beach on the left, but the generation path produces an image that mistakenly flips the layout. However, the bottom path reveals that the same model can accurately critique this failure, correctly identifying the error. The central idea is to use this robust internal understanding to strengthen and guide the model's generation process. So, while the previous figure illustrated the problem, Figure 2 presents the solution in action. This showcase displays 4 generated samples that demonstrate the model's versatility. For instance, the top left panel features a neon sign, while the top right shows an intricate papercraft design. Crucially, the model accurately renders text in both the neon sign and the book cover at the bottom right, spelling UniCorn correctly in both cases, which suggests the self-improvement strategy successfully restores fine-grained control. Alright, Figure 4 breaks down the complete framework, showing how these self-improving loops actually function. Panel A on the left illustrates the self-multi-agent sampling process, where the model splits into proposer, solver, and judge roles to generate and score its own training data. Then, Panel B details cognitive pattern reconstruction, which converts these interactions into learning tasks like captioning and reflection. Finally, Panel C introduces the unicycle benchmark, verifying that the generated image accurately preserves the prompt's key details. So, while Figure 4 detailed the training pipeline, Table 1 presents the concrete results across 6 benchmarks. It compares UniCorn against top contenders like Flux 1 and unified models like Genus Pro. Focusing on the bottom rows, the gains over the base model, Bagel, are substantial. Specifically, the model achieves a massive 22-point jump in text rendering on the 1IG benchmark. It also secures state-of-the-art results elsewhere, reaching nearly 89 on CompBench and about 87 on DPG, confirming that the self-training loop effectively sharpens performance. Okay, moving from the main benchmarks, Figure 7 investigates the scaling behavior on the TIIF dataset. Here, the bars represent scores for short prompts, while the blue line tracks performance on long ones as the dataset grows from 1,000 to 20,000 samples. We see a steady upward trend, indicating that the model continues to learn effectively from its own output. Most notably, the highlighted region at 5,000 samples marks a tipping point, where UniCorn surpasses powerful baselines like DAL-E3 and IRG, demonstrating impressive data efficiency. Well, verifying that generated images actually match their descriptions requires more than just a single score. Figure 10 visualizes the unicycle benchmark, which runs a round-trip test, generating an image, then asking questions to see if the key details survived. The top row shows a failure where the spatial layout is lost, resulting in a 0 score. In contrast, the bottom row is a success. The model renders the light bulb text accurately, and the checking phase recovers every word, confirming high fidelity. Wrapping up, 2 takeaways stand out. UniCorn proves that models can self-correct efficiently without external teachers, and that leveraging internal critique successfully bridges the gap between passive understanding and active generation. This suggests a scalable future for self-supervised multimodal intelligence. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.